Hello everyone. In this video, we'll see more problems in joint probability. So the first question is the joint probability for two random variables x and y is as follows. So we have to find the marginal probability of x and y, and the second one is correlation of x and y. Third one, p of x plus y greater than 0, and at last we have to verify that x and y are dependent random variable. Okay, so the tabular column that has been given is a joint probability table because we have both values x and y. These are the x values. X takes the values 1 and 2, and y takes the values -2, -1, 4, 5. Correct? And what is the probability? The probability corresponding to x is equal to 1 and y is equal to -2 is 0.1. The probability corresponding to x is equal to 1 and y is equal to -1 is 0.2. So like that they have given the probability. So now we have to find the marginal probability of x and y. Correct? So first of all we have to write down the values of x. Yeah. Now if you see x is taking the values 1 and 2. So I have written these values here 1 and 2. Now we have got 0.6 and 0.4. How? Because for x we will add all the values that is there in each row. For example, if you see the table, yeah, now it's visible. So 0.1 plus 0.2 plus 0 plus 0.3. So this will give 0.6. That is what we have written here. Now for the corresponding value of 2, what are the values in that row? 0.2 plus 0.1 plus 0.1 plus 0. So 0.1 plus 0.1 is 0.2, 0.2 plus 0.2 is 0.4. That is what we have written here. Similarly for y, what are the values of y? -2, -1, 4, 5. So we have written these values over here. So below -2, what is the value? 0.1. Now we are going to add column wise. 0.1 plus 0.2, 0.3. 0.2 plus 0.1, 0.3. 0 plus 0.1, 0.1. And the last value 0.3 plus 0, 0.3. So these are the marginal probabilities of x and y. So what you are going to do? For x values we will add row wise, because for this one we will add this corresponding value. This is a y value because if you see the tabular column, x I have written here, y I have written on the top. So this is y value and this is x value. So when I'm writing y value -2, I'll add these two and I'll write it here. So this is the marginal probability of x and y. Now we'll go for the next one, that is correlation of x and y. What is the formula to find the correlation? Yeah. So this is the formula. Correlation is nothing but covariance of x comma y by sigma x and sigma y. So what are the things that we require? We need covariance of xy, we need sigma x and sigma y. So automatically what is the formula for covariance of xy? Expectation of xy minus expectation of x into expectation of y. So first of all I have to find expectation of x, then expectation of y, then expectation of xy. Correct? And then for sigma x, first what we'll do, we'll find sigma x square and then we'll take the square root. What is the formula for sigma x square? E of x square minus mu x square. Sigma y square is E of y square minus mu y square. Correct? Mu y is nothing but, mu x is nothing but expectation of x. Both are same. And mu y is nothing but expectation of y. So first I have to find expectation of x and expectation of y. So to find that, what is the formula? Expectation of x summation xi f of xi. So we have to refer the individual tabular column. So it is there in the previous page. So one sec. Yeah. So expectation of x is 1 into 0.6 plus 2 into 0.4. Similarly, expectation of y is -2 into 0.3 plus -1 into 0.3 plus 4 into 0.1 plus 5 into 0.3. This is what I am going to write. So I have written the same. So expectation of x is 1 into 0.6 plus 2 into 0.4. If you simplify this, expectation of y, I told you all these things. So if you simplify, you will get 1. So you got expectation of x, expectation of y. Now you have to find expectation of xy. This you have to get it from the given tabular column. First we'll write x value, y value and the corresponding probability. So you have to see the joint probability tabular column that is given in the question. I'll show that once again. So this tabular column I was talking about. So 1 into minus 2 into 0.1 plus 1 into minus 1 into 0.2 plus 1 into 4 into 0 plus 1 into 5 into 0.3 plus next line 2 into minus 2 into 0.2 plus 2 into minus 1 into 0.1 plus 2 into 4 into 0.1 plus 2 into 5 into 0. This is expectation of xy. So we'll write x value, y value and the corresponding probability. So same thing I have written here. So expectation of y, if you simplify, you will get 0.9. So covariance of xy, what is the formula? Expectation of xy minus expectation of x into expectation of y. So expectation of xy, just now we got 0.9 and expectation of x we got 1.4, expectation of y we got 1. So by substituting the values you got covariance. So now what we have to find? Correlation coefficient. What is the formula for correlation coefficient? That is covariance of x comma y divided by sigma x into sigma y. So we have to find sigma x and sigma y now. So I have kept the tabular column over here so that it will be easy for us. So sigma x square, and to find sigma x square and sigma y square, first we have to find expectation of x square. Correct? So expectation of x square, how we have to do? That is 1 square into 0.6 plus 2 square into 0.4. That is what I have written. When you simplify this, you will get 2.2. Expectation of y square, you have to see y tabular column. Minus 2 square into 0.3 plus minus 1 square into 0.3 plus 4 square into 0.1 plus 5 square into 0.3. So I have written this. This is expectation of y square. So if you simplify, you will get 10.6. So you got expectation of x square as well as y square. Now we are writing the formula sigma x square. This is nothing but expectation of x square minus mu x square. Expectation of x square, just now we got it as 2.2. So 2.2 minus expectation of x that we got it on the previous page. So it is 1.4 square. This mu x and expectation of x both are same. Okay. Similarly, sigma y square is e of y square minus expectation of y the whole square. So expectation of y square, just now we got 10.6 minus e of y we got 1. So 1 square. So if you simplify, you will get this. So finally we are substituting in rho of x comma y, that is covariance of xy divided by sigma x into sigma y. So we are taking the square root. What we got is sigma y square. So if you take the square root, you will get sigma y. So this is correlation coefficient. So even if they ask correlation coefficient, indirectly anyhow you have to find expectation of x, expectation of y, expectation of xy, expectation of x square, expectation of y square, sigma x square, sigma y square, and then only we can find correlation of x and y. So now the continuation of the problem. So I have to check whether it's independent or not. Correct? If f of xi and g of yj is equal to jij, then it is independent. So we are going to take what is f of xi. Correct? It's there in the question. F of x1 I am taking for a change. F of x1, if you see 0.6 and g of y1 is 0.3. So I am taking these two values. So f of x1 is 0.6, g of y1 is 0.3. And what is J11 from the marginal probability table? J11 is 0.1. If you see this is the first value. J11 is 0.1. So I have written all these values. 0.6, 0.3, 0.1. So definitely 0.6 into 0.3 is not equal to 0.1. So x and y are not independent. Therefore x and y are dependent random variables. So we are done with the second subdivision also. Okay. So one more thing. Yeah. So one more thing is, in the question itself they will give. Correct. So for example, suppose x and y are independent random variables. They have given it in the question with the following distribution. Find the joint probability of x and y and also verify covariance of x comma y is 0. So in this problem we have seen the joint probability table and we formed the individual table, and then finally we proved that they are dependent. But here in this problem, they have given that x and y are independent. So it's a clue. Okay. So, and they have given individual table, x and y, they have given individual values. So they are asking us to find the joint probability. And already I told you, if it's independent, we know covariance of x comma y definitely will be 0. Correct? So we have to prove this. So now the probability for 1 and 2, they have given 0.7 and 0.3. In y, the probability for -2 is 0.3, 5 is 0.5 and 8 is 0.2. So how to find out? So we are going to use the same formula. If it is independent, we know that f of xi into g of yj is equal to jij if it's independent. So they have given independent, so we are going to use this in the tabular column. Yes. So now I have formed a joint probability table, x values, that is 1 and 2, because in the question they have given, if you remember, x values they have given 1 and 2, y values -2, 5, 8. So I have written this -2, 5, 8. These are the y values. Okay. So for this corresponding, I am just naming it as J11, J12, J13, J21, J22, J23. Okay. So now if I add all these values, that is f of xi, correct? In the question they have given in the individual tabular column, what is f of xi in the first row? 0.7, second row 0.3. So I have written that 0.7, 0.3. Similarly, column wise all the values are nothing but g of yj. In the previous problem, they have given the joint probability, we found that individual table. Now individual table is given, we have to find the joint probability with a clue. What is that clue? X and y are independent random variable. So now these are the values of y. If you see here, again I will show you this, 0.3, 0.5, 0.2, g of yj. So I have written this 0.3, 0.5, 0.2. So now the total probability will be always 1, that we know. 0.7 plus 0.3, 1. And then again if you add this row wise also, 0.3 plus 0.5 plus 0.2. So automatically it is 1. Now since the x and y are independent, so if you multiply these values, you will get the corresponding J11, correct? So J11 is 0.7 into 0.3. So this is J11, because what is the formula? F of x1 is this, g of y1 is this. So if it's independent, f of x1 into g of y1 is equal to J11. This is the formula, correct? F of xi into g of yj is jij. So f of x1 into g of y1 is j11. So 0.7 into 0.3, 0.21. What is the next one? 0.7 into 0.5. This is the next value. Okay. So this is j12. 1 is fixed here. That is why 0.7 I am taking. Next one is j21. What is the second value? 0.3. So 0.3 into 0.3 is 0.09. The next value is 0.3 into 0.5 is J22. The next one is 0.3 into 0.2 is this value. Just we are using the formula f of xi g of yj is equal to jij. I repeat how you got J11. You write J11, J12, J21, J22 and J23. Okay. So here the first value is same, J11. Here J12, 1 is same. So 0.7 into 0.3 is the first value. 0.7 into 0.5. This is the second value. Okay. So J13 is, I didn't write J13, right? J13 is 0.7 into 0.2. Wait, I'll write that also. Yeah. So I have written J13 also. That is 0.7 into 0.2. So 0.14. So for the next row, J21, J22, J23. First value is 2, right? 2 is same. So I am going to take 0.3. 0.3 into 0.3 is first value. 0.3 into 0.5 is second value. 0.3 into 0.1 is the third value. 0.3 into 0.2 is the third value. So we got all the values. Just we have to write down these values in the tabular column. So what we have to prove? Covariance. Covariance already just now we saw in the previous problem. It is expectation of xy minus expectation of x into expectation of y. As I told you, mu x is same as expectation of x. I told you mu suffix x and expectation of x, both the values are same. So expectation of x is xi into f of xi. So you have to multiply x and the corresponding values. So if you see the question, x value is this. I hope so. This is the same question. 1 into, yeah, the same question. So 1 into 0.7 plus 2 into 0.3. This is expectation of x. So I have written the same. 1 into 0.7 plus 2 into 0.3. What is expectation of y? So minus 2 into 0.3 plus 5 into 0.5 plus 8 into 0.2. I have written this. So if you simplify, you will get 3.5. For expectation of xy, we will use this joint probability table. Correct? What is expectation of xy? 1 into, I'll show this. 1 into minus 2 into j11. j11 value we got as 0.21 plus 1 into 5 into j12. j12 is 0.35 plus 1 into 8 into j13. j13 just now we got 0.14 plus 2 into minus 2 into j21 plus 2 into 5 into j22 plus 2 into 8 into j23 plus 2, this is the last value. So j23. So we have to find out expectation of xy, and that answer is 4.55. This is expectation of xy, 4.55 we got. So after simplifying this, what is the formula for covariance? Covariance of x comma y is expectation of xy minus expectation of x into expectation of y. So 4.55 minus 1.3 into 3.5. So if you simplify this, answer is 0. So this covariance part is similar, only this is new. That is, we are using that x and y are independent and we are forming the joint probability table. This is type 2 problem in joint probability. So we'll see one more question. The joint probability of two discrete random variable x and y is given by f of x comma y is equal to k into 2x plus y, where x and y are integers such that they are giving the x range. X varies from 0 to 2, that is 0 less than or equal to x less than or equal to 2, and y values 0 less than or equal to y less than or equal to 3. So now what are the questions? Find k is the first question. Second one, marginal probability. Third one, show that x and y are dependent. These are the things in this problem. Yeah, now if you see, I have taken x values 0, 1, 2, because in the question they have given 0 less than or equal to x less than or equal to 2. Since less than or equal to is there, both the end values are included. Y values what they have given? 0 less than or equal to y less than or equal to 3. So what are the y values? 0, 1, 2, 3. These are the y values. So now we have to form the tabular column. So f of x comma y, what is the formula they have given? That is in the question itself, k into 2x plus y. So we'll just write down x values 0, 1, 2. Y values here 0, 1, 2, 3. Now we have to just substitute it in the given formula. So what is the first one? For example, k into, here x also 0, y also 0. 2 into 0 plus 0 into k. So your first answer is 0. What is the second answer? That is x0, y1. K into 2 into 0 is 0 plus 1 k. Second one, x0, y2. K into 2 into 0 plus 2. Okay. So 0 plus 2 is 2, 2k. Same way, x0, y3. So k into 2 into 0 plus 3, 0 plus 3 into k, 3k. So we can, like that, you can substitute the values and check. Randomly, we'll check one value here. Here x2 and y also 2. So if you substitute here k into 2 2s are 4, 4 plus 2, 6. So 6k. So you got this. So you have to substitute all the values and write it down in the tabular column. And right extreme I have written sum. The sum is nothing but all these values are f of xi. Correct? This is f of x1. This is f of x2 and all those things. So 0 plus k plus 2k plus 3k is 6k. 2k plus 3k plus 4k plus 5k, 14k. Then 4k plus 5k plus 6k plus 7k, 22k. So we have written row wise, and that is nothing but f values. So now how to find the g values? We have to add column wise, correct? 0 plus 2k plus 4k, 6k. K plus 3k plus 5k, 9k. 2k plus 4k plus 6k is 12k. Finally, 3k plus 5k plus 7k is equal to 15k. Now we got all the k values. Similar to the discrete version, what we'll do, when we add all these values, the summation should be equal to 1. If you add this way or this way, anyhow you will get same value, 42k. So even if you make any silly mistake, this way if you add and this way also if you add, you should get the same value. If you get the same value, then you didn't make any mistake. If you are getting different value, then you might have done some silly mistakes in the calculation. So adding these values, 6k plus 14k plus 22k. So what you are getting? 42k. So 42k is 1, therefore k is 1 by 42. That's it. So this is a total tabular column. So when you are writing it in terms of individual tabular column x and y, so we are writing the values x, 0, 1, 2. So here what is the summation we got? 6k. So 6 into 1 by 42. 9, x values, right? X values here. Because these are the x values. X we have to add row wise. So, so first row 6k. So 6 into 1 by 42. Second row when x is 1, answer is 14k. So 14 into 1 by 42 here. And third row when x is 2, 22k. So 22 into 1 by 42. That is 22 by 42. You can of course simplify these values. So y is all column wise answer, right? So y takes 0, 1, 2, 3. So we have written that values here. And what is the first value? 6k. That is 6 by 42. Second value 9 by 42. Third value 22 by 42. Fourth value 15 by 42. So I have written this here. Okay. So we got the joint probability and the probabilities of x and y. Now what we have to check, whether these variables are dependent or not, is what we have to check. Correct. So 6 by 42 is first one. Here first answer is 6 by 42. And if I multiply these two, if you get this, then it is independent. But this value is 0. So 6 by 42 into 6 by 42 is not equal to 0. So hence the random variables are dependent. It is not independent, so automatically it is dependent. So we got k and we proved the random variables are dependent. So we have seen three problems. The first problem, they've given the joint probability, they asked you to find marginal probability. Second one, it's like they've given the individual probability, random variables of x and y, and we have to find joint. And the third one, finding k. So these are the types of problems in joint probability. Thank you.